Okay, 8.1 is about relations and functions. So relations is a special x, y, it's just an x and a y. So you can graph an x and a y, you can write x and a y as a list of ordered pairs, you can do what's called a mapping, which is right here, and I'll show you how to do that. But it's just a relationship between an x and a y. A function is a special type of relationship, such that for each x there's one special y. So you have all of these relations, and only some of them are functions. So domain is all x values. We also call them inputs. Or you can also see it in science maybe too as an independent variable. It stands alone. Okay, a range is the y values. They're the outputs. They are the dependent variables. And then a function is a special type of relationship such that for every x there is one unique, a special y. So which makes something special or unique? It's the only one. So I'll show you with examples that are coming up, but okay, so let's look at, we're going to make what's called a mapping. Oops, I didn't mean to do that here. We're going to make what's called a mapping here. So the domain, remember, is the x values and the range is the y values. So what I'm going to do is, given this relation, remember a set of ordered pairs, these brackets right here means it's a set. So we're going to list off the x's, just how they come up here. So I see 11, a 12, a 13, and a 20. And then we're going to list the y's. I see a -2, a -1, and a 7. Now, I don't need to write -2 twice. I only write it once right here. And a mapping is going to be show the connections between what does 11 match up with? Well, 11 matches up with -2. 12 matches up with -1. 13 matches up with -2, and 20 matches up with 7. Okay, so then the second question is this relation a function? Yes, it is, because each one of these x's only has one line coming out. The 11 only goes with -2. This 12 only goes with -1. This 13 only goes with -2. 20 only goes with 7. It would not be a function if you had something like this. If you had 20 going with -1. There's no way that 20 could go with -1 and 7 at the same time. Think of airports. Think of this being the airplanes, and this being an airport. There's no way at one time that plane 20 could land in Grand Rapids and Detroit. Nope. But you could have a plane go to Grand Rapids and this plane go to Grand Rapids. That's fine. So let's try letter B. So domain, list all the x values, just how they come up and don't repeat. So -2, -1, and 6. Again, I don't need to write this -2 twice. So now I'm going to do the y values. -1, 0, 3, and I don't need to write 1 again. So -2 goes with -1, -1 goes with 0, 6 goes with 3, and then -2 goes with, oops, I forgot +1. I missed that +1. So this one is not a function because there's no way that this airplane could go to 2 different airports at the same time. So -2 can't go with -1, and -2 can't go with 1. This means that this y is not special. So no, this is not a function. Okay, so a vertical line test is a way that you can show graphically something is not a function. So a graph is a function if you can draw vertical lines, so vertical goes up and down, through every point and the lines never hit 2 points at the same time. Sometimes I hate writing out these definitions because they're really longer than they need to be. It's easier to show with pictures. So let's plot these. So -6, -5. 1, 2 is off the charts. So it's over here. -3, -2, 0, -2, 1, 0, and then 4, 3, and 5, 7. So what the vertical line test is saying that where all these points are, I'm going to draw vertical lines, these green lines. And does this green line touch another point? No. Does this green line touch another point? No. Does this one? No. This one? No. This one? No. This one? No. So yes, it is a function. So then I'm going to do it again over here. So -7, 4 is off the charts again. -2, 6 off the charts. -1, -1. -1, 3. 0, 5. And 1, 5. Now I'm going to draw vertical points, vertical lines through each part. These are horrible vertical lines. Okay, so you can tell that right here and right here on your chart that this x has 2 different y's. So that is not a function. There's no way that that can happen. So I'm going to show you more. Okay, so I'm going to show you more with the vertical line test. Here's your xy axes. Oops. I'm going to draw a relationship in green. Okay, so here are they're not functions, not necessarily, these are relationships, and we're going to use the vertical line test to see if it's a function. So this one, my blue line, never crosses the green line more than once, so yes, it's a function. This one, oh, crosses twice, so no, it's not a function. This one is yes. This one, nope. Crosses these twice or multiple times, so no, it's not a function. And this one, yes, it's a function. These arrows don't count here, they're just always at the end of functions.